This chapter, we're going to be looking at powers. This is going to lead into exponentials and all of that other stuff, but this is the base that we need to kind of work with first. So in this video, we're going to talk about power functions. So this is when we're looking at when we're raising something to a power or an exponent. So if I were to have x squared, we know that x is taken to the power of x, which means that it's x times x. Okay, so this we know is a square. If I were to have x cubed, this would be x times x times x. Anything after that does not have a special name. So for instance, if I have x to the fourth, this is x to the power of 4. So there's no special name after that. Oh, I forgot x to the first. This is what we call our identity. I didn't list it up there just because you're taking it to the power of 1. It's the same number, so you know it's going to be an identity. But with that, we are going to be looking at the graphs of these different types of functions. We're going to be looking at different types of properties for this. So for example, if I have x cubed, I could show you on a graphing calculator, but I'm just going to draw a rough sketch of this. X cubed is going to look like the graph on the right here. So we need to state the domain. We need to state the range and any other characteristics we might have. So looking at our domain, so remember the domain are our x values. Can we pick any x value? Or another way to look at it, how far to the left does it go? How far to the right does our graph go? Okay, so when I'm looking at this, the domain, it keeps going on forever in the left. So that's going to be negative infinity. And it keeps going on forever in the right. So that's going to be positive infinity. Now for the range, we're looking how far down does it go? How far up does it go? And that's all in terms of just the y values. So if I'm looking at going down, it goes down forever in the negative direction. So negative infinity. And in the positive direction, it keeps going on forever as well. So that's positive infinity. So looking at this, we know the domain is negative infinity to positive infinity. The range is negative infinity to positive infinity. Well, there are cases where you don't actually need to graph it in order to determine this. And I say that because we're raising it to the power of 3. 3 is considered odd. So this is an odd function. So what does that mean? That means that our range has to be from negative infinity to positive infinity. The domain, regardless of whether it's even or odd, is going to be the same, but the range is from negative infinity to positive infinity. We also know that with an odd function, we have rotational symmetry. So going back to geometry, if I'm here, I can rotate, if I rotate this right here, and I rotate it this way, it's going to be here. Okay, so that's what the rotational symmetry is talking about. The other thing is With this, we will pass through the origin, which is the same thing for an even. So since this was an odd function, we need to look specifically at an even function. Horrible sketch, sorry. So looking at this, our domain, we can pick any x values. Our range, though, depending on where your point is, your range for this specific graph that we are looking at is from 0 to positive infinity. By the way, in case you were wondering, notice with infinities I have a parenthesis, and with the 0 I have a bracket. There is a difference. This is a little side note here. This does not touch point, includes point. So kind of like when we're doing inequalities, you have an open circle versus a closed circle. An open circle, you do not include the point. The closed circle you do. It's the same thing with the parentheses versus the brackets. So we have a bracket. Whenever you see infinity, it'll always be a parenthesis. We have a bracket around the 0 because it does actually touch 0. So that's just a little side note. Like I already told you, this is an even function. Therefore, we know the range is going to be different. We also know that this is going to have reflection symmetry. And we're going to pass through 0, 0. This can all change. This is what we call a parent function because it's a pure function. It's x squared. This could all change if I take x squared plus 6, or if it was x squared plus 3x plus 9. It can all change depending on what's happening after. But this is what we call our parent function because it's the pure form. There isn't additional terms after that.